Thank you very much. Okay, thanks. Okay. Thank you, Toon.
Yeah.
Thank you.
Yeah, welcome Toon Peters. He made the way from Belgium. He will talk about picoTCP. He will explain what it is. Have fun.
All right. Let me put my timer.
Yes, I will show you the time. Don't worry.
Who is giving a presentation in this nice room. And I come from Belgium to talk to you about picoTCP. And it's a piece of software we've developed under Intelligent Systems Division of Altran. So it's a commercial company who has been working on open source software, which is not always an easy choice. And I'll tell you a bit about what picoTCP actually is. So picoTCP, as is part in the name already, is a TCP/IP stack that is designed for small footprint embedded devices, so really the small devices. If this doesn't ring a bell yet, I'm going to try it in a different, more visual way. So on the left you see one of the RFCs for TCP. So we are implementing standards that have been released, and these standards leave open quite some to interpretation, so you can implement them in many different ways. We did so optimized for the small embedded devices, so we don't assume to have a big server infrastructure with a lot of storage and a lot of processing power. No, we assume that we have a very small device, as you see on the right, that you have to program bare metal and that you have very few resources available. And picoTCP has been written in C. So it's really a piece of software that you can compile and run on your device. You can do it standalone if you want. You don't need an operating system. And yeah, with that, I hope you kind of understand where we are now. Sometimes I already lost people. It really depends on the level of technology knowledge. Somebody in the room who really says, like, I still don't know what you're talking about? Cool. Okay, then I'm going to continue to my further slides with all these other ones. It's just the fact that we've implemented in a specific way. So the end of 2012, he managed to put together a basic TCP implementation. So that's quite a chunk of an RFC that you have to implement. And probably at that point, it was not feature complete. But at the end of 2012, so nearing December, the company, then called TAS, decided, okay, we're really going to turn this into a company project. We're going to put some funding into this. We're going to make people available to work on this project. And then we could really step up the game a bit. So in 2013, we had our first hardware port. So it's made for embedded devices, but the whole 2012, we never actually run on an embedded device. With the development in Linux, and that's a big luxury because you don't need any special hardware. You have all the breakpoints and debug mechanisms that you want. On a small embedded device, you very often do not have. But yeah, at one point you do have to port it to a specific target. We started with IPv6 because IPv6 is necessary. We need to get it. We're running out of IPv4 addresses, and also on these very small devices. And end of 2013, IPv4 was done, and we started with a driver for a Wi-Fi platform. I don't really know which one anymore, but that's to be found out later. 2014 was a year where we did a whole bunch of different stuff. No big giant changes, but like adding features here and there. 2015, IPv6 ready, and we're still working on full IPv6 certification. But that's ongoing. Other protocols that have been asked for, like a TFTP, fun protocol for bootloaders. But MDNS, also a fun protocol, but not really for small embedded devices. It's probably the biggest module of the whole TCP/IP stack. So it's the one thing, if you have an Apple device, like the Bonjour stuff. Yeah, so you have all your Apple devices in home, and they all magically find each other. The MDNS is what's behind that. End of 2015, one of the students in the Netherlands wanted to do a project with picoTCP, so he implemented geo-networking which is part of the vehicle to infrastructure protocols. So also that, you can plug it in, it fits somewhere in the stack. 2016, we hope to reach full IPv6 compliance. We're working on 6LoWPAN, so that's really a protocol for the Internet of Things, and some other protocols too. So this gives you a bit of the history timeline. Now, I would like to focus a bit on what the focus areas were for picoTCP. What did we focus on? How did we build this? So to keep your code very portable and modular is something essential if you're working with embedded targets. So modularity, portability, super important, but also the quality thing. And that's something that is an afterthought in many projects, and sadly in open projects, no less. Huh? You want to see functionality, not really tests that are blinking happily to green. But we did design it in. So modularity, picoTCP core, it's all built around one single core. By default, it's a bit of an event loop. It just schedules, go through the OSI stack layers and executes all of these. And then you have all of the modules built up around it. And these all together form what we now have as the full picoTCP stack. And if you compile everything, you have 105K of flash requirement. So it's a pretty big chunk. But since it's modular, you can also decide to not take everything. If you take, for example, IPv4 with UDP, you can fit it all in 16K of flash, and that's much smaller. So you can really, you can think of even the 8-bit platforms if you would want. That for modularity, very essential to work on embedded targets. This is a bit how you do it. So we use makefiles, all the good C magic. And you just compile it with all these macros to set which modules you want. And out of it comes a very nice binary, and you can flash it on your device. Portability. So as I said, picoTCP has been, from the ground up, been designed in Linux. And we've decided to not use any special libraries, to not work with unique features of different architectures. So your code is really CPU architecture independent. So you can do 8, 16, 32, 64-bit, big, little endian, doesn't matter. We have, for certain of these things, we have built in some functions so you can really be sure that it will work on your device. And as I said already, we can run bare metal, so you can just put picoTCP on a device and it will run. We can also work in operating systems, RTOSes, and some other stuff. And then I have a very big list because I wanted to be complete with my explanation. So a bit of different platforms that we work on, 32, 64, 16, 18, and 8-bit. So we go all the way down to 8-bit devices. It's a bit of a fun experiment, not very practical. So we can run on an Arduino Atmega 328, but you need some extra RAM outside because otherwise you're not getting very far. We have a whole bunch of chips that we support. We have virtual drivers, and that's the thing we use to develop on Linux. So you have Toon, Tab, VDE devices. You can do a whole lot of cool things in Linux with these. We work on different compilers. So you have the standard GCC that we all have been using a lot, but all the other compilers we have also been working with to port it to these specific targets. All the operating systems. So we also run in Linux. That means in user space. But as a fun experiment, we've also run it in the Linux kernel by throwing out the Linux kernel TCP/IP implementation and putting picoTCP in place. Practical use at this moment, not that much. But the cool thing is you could reduce the flash size or the flash requirements of the Linux kernel by 100 or 200K. Which is quite a bit, so you can put Linux then on even smaller devices if you would want to. And compatibility with some other things. And the quality part, if I tell this to students, then they are like, yeah, never thought of that. That's really not something we do. So as we are doing this from a company point of view, we're kind of forced. We have some managers who like to force us to ensure this quality matter. But we also have the tools, and that's a cool thing. So we can use commercial tools. We have some money available to do so. So that means we do unit tests, of course. But we also check for compiler warnings. We check on the different compilers and see if we get warnings. We do static code analysis, where we get this very nice label on the right side. So it's not just a fridge label. It's really a label that we have that says this is the code quality of picoTCP from a static analysis point of view. So we're now at a B, and we also always want to get higher. So on our repository, you will see some issues saying, like, okay, this module needs a bit more of this, and that module needs a bit more of that. We also do dynamic analysis. So stuff like Valgrind, you compile in, and that's the only way to ensure that you don't have memory leaks, or that you do very special accesses in out-of-bounds accesses of an array, for example. SC happily allows you to do all of these things most of the time. And lastly, and this is very important if you're writing an implementation of standards, is RFC compliance checking. So we use existing tool sets. We have written our own for some things. And that ensures that we can communicate with existing implementations. One of the fun things, and you have to learn that the hard way, is that Windows has this very special way of implementing things. So if you're running in an environment where you have a Windows DHCP server, you can expect yourself to do some special modifications just for Linux, for Windows itself. And the last thing, and I didn't mention that yet, and if this slide would not be here, I would not even be standing here, is that picoTCP is available on GitHub under a GPL v2 license. And that this is really important for not just a project like picoTCP, but I think for the whole world of the Internet of Things. We really need to have an environment that's based on open standards, open implementations, so that people can use and reuse these implementations instead of just creating their own every single time. So you can check us out on GitHub, clone, do whatever you want under GPL restrictions, of course, but there's a Getting Started guide, check it out there. The cool thing about this community is, of course, that you get community projects. So some guy comes to us and says, yeah, I want to integrate this with Barebox. We say, okay. So he brings us a couple of compiler warnings that he got from his specific compiler. We fix them, and then suddenly you have the full picoTCP running in Barebox, where you used to have only a TFTP implementation on top of something kind of not really fully RFC compliant. Other things, that's RPython. I forgot the name of the project. So where you can run Python on a microcontroller. Also there we have bindings for picoTCP, so you can set up a socket from your Python code and it's all running. Same story for Rust, the new C. So far still has to make its way to the big audience, but yeah, okay, there too, an implementation. We've also implemented with other products, other companies, their products. One of them is Wolf SSL. So picoTCP does not have an SSL implementation from ourselves. We've decided to there stick with what other people have already done and who did not get issues with any Heartbleed bugs and stuff like that. So Wolf SSL is doing a good job. We have implementations with them, and you can also compile them straight on top of picoTCP. Mongoose is the thing on the right. Another project, more application level applications. Yeah. And last thing, and sometimes you get pretty weird things. So a guy comes to us and says, yeah, I would like to run picoTCP on DOS. You're wondering how many people are still using this, because apparently there is still a whole community who is actively working on DOS and improving it. So now they have picoTCP in DOS. That's a full TCP IP stack. So yeah, cool stuff. Here, that's yours. I hope that some people here in the audience will be like, yeah, perfect match for my little project. So please do let us know if you do something with picoTCP. We love to hear about your stories, and we like to share them too. And And at 4 p.m., I will also give a workshop about picoTCP. So if you brought your little Linux environment, your laptop, feel free to join. I think it should be somewhere on this floor. And to give you an idea of what we will be doing there, we're going to write a little application on top of picoTCP. So really an application where you can do something functional. And that's the kind of code you're thinking of. This is what you will be writing. So it's pretty straightforward. And in 2 slides of code, that's one, but whatever. In 1 slide of code, you actually have an application that can reply to pings, ICMP ping messages. Someone doesn't like picoTCP. I'm sorry. It's probably the code. So this is a bit what we are going to do in the afternoon. We have about 2 hours for that. So if you have 2 hours to spare from 4 to 6 p.m., please feel free to pass by and check us out. And with that, I'm going to wrap up already because I want to leave some room for questions. I'm really curious if there are specific questions or maybe some very difficult questions that I will not be able to answer. So please feel free to shoot.
How many people are working on the code now?
Counting the number of people is a bit difficult. It varies a lot, of course. Main people working on it are still from Altran. But the cool thing is that these people don't work on it during their working hours, apparently. And you can really see that on GitHub when you see the most commits. Like, a lot of stuff happens somewhere like deep in the middle of the night. So I don't know what our engineers are doing, but they have a second life at night where they contribute to these kinds of projects. The other kind of contributions are mostly in like integrating it with their project, something like the DOS integration or things like that. The community is still fairly small, but here and there it picks up, and like there is an operating system that is in need of a TCP/IP stack. They just take our code, integrate it, and they're ready to go. Yeah, shoot.
Did you go through any kind of security audit?
So let me repeat the question, because the cameraman will like that. So he asked, did you already put picoTCP through any security audit? There the question at this moment is no. It's really something that should be done, because even though you're not implementing an SSL implementation, your implementation of these other protocols should be secure. The way we try to prevent already something from going wrong is doing all these quality checks. So by doing dynamic analysis, we can get some out-of-bound accesses out of the stack, which can make it already more secure. But like really penetration testing and really like doing the bad stuff with it, not yet. So if you feel to let go like a random generator on picoTCP and tell us where everything is crashing, then we would love to hear about that too. Who has a project that picoTCP could integrate with? Really?
Similar projects to picoTCP.
Yeah. So the biggest, I can call it competitor, even in the open source world there are competitors, is LWIP. It's a TCP/IP stack that has been out there for quite a long time. And this is really more of an organic stack. So it started as a university project, and then people joined, and modules get added, and this gets a bit reworked, and you get more implementations. And it's actually a stack that is very widely spread because it's released under a BSD license. So from a commercial point of view, this is very interesting for companies to just take this stack. The thing we had with LWIP is that it's a very monolithic block. Because it has been written by so many different people, it's not super modular. The code base is, let's call it, dirty. You have so many contributions. And it's also not actively being updated anymore. Like, I think beginning of the year they had another release where they finally had IPv6 and IPv4 at once. You have the dual stack feature. That was something that was designed in picoTCP, that you can run them both at the same time. And with LWIB, it's more of an afterthought. Yeah, or did that answer your question? Everything clear? Okay, thanks. Yeah.
So, have you tested what's actually the smallest or cheapest microcontroller that works on?
The smallest, but I don't know if cheapest applies. So the smallest we could do was the Atmega 328. So that's a thing you also have in Arduinos. But you need some external hardware. I think you could fit a very, very basic implementation where you can do like ICMP messages. You could all fit that in the Arduino. But as soon as you're doing TCP communication, then you run out of RAM very, very quickly. You need like a window size of RAM already available to you. And that ingoing and outgoing is easily 3K of RAM. And I'm not sure, but I don't think they have that. So we do that, but we can go all the way to the other end of the spectrum. No? Okay, then I'm going to wrap up. If you have any more questions, I will be wearing my green shirt for the rest of the day, so please feel free to stop me. You can check us out on GitHub. If you manage to get it compiled today, which you should be able to do in 15 minutes if you have a Linux box set up, let me know, and maybe we can do something more in the afternoon. Thanks for your attention.